So we'll start by discussing some general form of the curves, like which type of curves do we get for different equations. First, we will start looking at, and then after that, we will solve the questions. So in the first, we will see how do we get the curves that are for the equations that are in the form y equals to x n, where n has got different values, but we will start with n has the value 1, 2, 3, and 4. So what type of graph will we get if we have the value of n as 1? When n will be equals to 1, the equation that we will get, it would be equals to y. It would be like y equals to x power 1. Which type of equation is it? What do we call it?
Um,
Is it linear, quadratic, cubic?
it's linear.
Yes. Whenever we have a power of 1, it's a linear equation. And for any type of linear equation, the graph would be a straight line. It would always be a straight line. So it would be like this. This is the simplest form of graph. When the power of the variable it's 1, the highest power of a variable it's 1. This is the graph that we will get. Then if I have the value of n as 2, if n is equals to 2, the equation would be y equals to x square. What type of graph do we see when we have the variable, when we have a value of 2 as a power of the variable? What
It's a
type of graph?
parabola.
Yes, it's a parabola. And is it concave up or concave down? Normally, when it's simply y is equals to x square.
Um, it'll be in a U shape.
Yes, it would be concave up. This is what we call as concave up. So for all the values of x, the value of y will be positive. For all x, y is greater than 0, except when x is equals to 0, because when x will be equals to 0, y would also be equals to 0. So this is the second type of graph that we see. Then we have a third type of graph, which we get when the value of n is 3. So this is what we call as a cubic equation. Y is equals to x raised to the power 3. This is what we call as a cubic equation. And in this case, we see a graph which looks like this. It would be like this. After that, we will see there are some other conditions as well that will affect our graph. Like it would be either like this or it would be like this. It also depends on some factors. But right now, generally, if it is simply y is equals to x3, it would be something like this. The graph would be like this. Then if we have the value n is equals to 4, the equation would be y equals to x raised to the power 4. So its graph would be the same as the graph for quadratic equation, but it would be closer to the y-axis. It would be a little closer. It would be same like this. It would be a parabola. It would be concave up, but you can see that this is quite distant. It would be distant from y-axis, but this x raised to the power 4, it would be quite closer to the y-axis. It would be like this. So this is the graph that we get when we have y equals to x raised to the power 4. Okay, so these are the general forms or the general shapes of the graphs. After this, you should know what are the stationary points. What do we mean by stationary points
They are the vertices of the
of a graph?
parabola graph,
Very
or
good.
the turning points.
Yes, very good. Stationary points, which we also call as the turning points. They can be of two types. It can be a maximum point or a minimum point.
Mm.
Can be a maximum or a minimum, and we also call them as turning points or vertices. Okay, so if we have a quadratic equation, how can we tell that how many turning points or stationary points will we have if we just look at the equation or the given equation? How can we tell that? What's the relation? The number
Mm.
of turning points, they are generally, we can say,
There's usually one in the quadratic equation.
yes. So the relation is actually, you can say that the number of turning points, they are equal to n minus 1. It will be less than the highest degree in the equation. In quadratic, we know that the highest power is square. So 2 minus 1, it would give you a single turning point. So we will see that for a quadratic equation, we can say that the turning point, TP means the turning point, it would be 2 minus 1 and it would be a single turning point. We will see only a single turning point. Still, we can have two types of graph. It can be either concave up or concave down. So
Mm.
it can be either, it can have a shape like this, or it can have a shape like this. And how do we know, like, how do they differ? If the, for example, if I have a quadratic equation and it's in the standard form, I say it's ax squared plus bx plus c equals to 0. The constant, which is written with x squared, if it is a positive number, then we get concave up. If a is a positive number, if it's greater than 0, then we get a shape which is concave up. If this constant or this coefficient that is written with x squared, it's a negative number or it's less than 0, then we get a concave down. This is
Mm.
the difference. This is for quadratic equation. Then if we see the graph for cubic equations, we know in a cubic equation the highest degree is 3, so the number of turning points would be 3 minus 1, so it would be 2. So for cubic equation, the number of turning points would be 2. And in this case as well, you can have two types of graphs. We can see two type of graphs. It can be either we know that we will have two turning points, so it would be either like this and it can be like this as well, like the opposite of it, so it starts from here. So it can be like, you can say it can be like this. And which one do we get when the power of, when the coefficient will be positive? Which one will we get? When the coefficient,
The
that will be
first one.
x cube. Yes, if I have ax cube, like the coefficient which will be written with x cube, if it's positive we will get the first one, and if the coefficient that is written with x cube it is negative, we will get this one if a is 0. So if a, the coefficient is positive, it would be like this. If it is negative, it would be like this. This is for the cubic equations. Then if we discuss the graphs for a quartic equation, quartic has the highest degree of 4. So quartic equations, turning points would be 4 minus 1, and the number of turning points would be 3. So over here you can see that we have got only a single point. This is the turning point. Over here we have only this turning point, which we call as the vertex. And which of these is minimum and which of these is maximum? Which one?
Maximum
Yeah,
is first one.
this one?
Mm.
This is minimum.
Oh,
Minimum is a change from decreasing to increasing. So it was first it decreased and then after that it increased. So this is what we called as minimum. And it's actually change from decreasing to increasing. If you look at this one, this point, it is called as the maximum point. And maximum point is the one that represents the change from increasing to decreasing. Over here, you can see we have got two turning points, but because we know in a cubic equation we have two turning points, one turning point is gonna be this one is gonna be this one. Which of these is the maximum and which of these is the minimum?
the maximum is the one on the left, and the minimum is the one on the right.
Yes, very good. This is the maximum, and this is the minimum point. Similarly, we will have one over here and one over here. And which of these is the maximum?
Mm, the right one.
Yes, the right one. This is the maximum. And then the other one is the minimum. So you can see that if the coefficient with x cube, it is positive, we are having a maximum and then minimum. And over here, we are having a minimum and then a maximum. In a quartic equation, we can see that the turning points should be 3. So the graph would be like it would be like this. You can get a graph like this, or you can have a graph which would be like this. So, how many turning points can you see in both of these graphs?
3.
3. Very good. We have got one turning point, which is here. We have got one turning point, which is here, and one turning point, which is here. How many of these are maximum? Which of these is maximum?
The middle one.
Yes, very good. This is the maximum point that we have. What about the other two?
Mm. The middle one is the minimum, and the others are maximum.
The middle one is the minimum. This one?
Yeah. No, in the other one. I mean, in the. Oh,
No,
you're talking
I'm
about the
asking
same graph.
about.
Okay.
Yeah.
Yeah, the other two are the minimum.
Okay, very good. So this one is the minimum, and the last one is also a minimum. So you can see that in this graph, first we have a minimum, then a maximum, and then a minimum. So among these three turning points, two of them are minimum points, and one of them is the maximum point. If we move towards the next graph, which of these is the maximum?
The maximum is the left and the right one.
Yes, so this is a maximum, and this one is also a maximum, and this point is the, which point is this one?
The
It's the
middle one is the
minimum.
minimum.
Yes, very good. So you can see that the two graphs, they are opposite to each other. Over here we have a minimum, then maximum, and then minimum. Two are minimums and one maximum. But over here we have two maximum, and then in between we have one minimum. They are opposite to each other. So it has two minimums and one maximum, and it has two maximums and one minimum. You will get the first graph with two minimums when the coefficient of x4 is positive. If I have ax4, a term in the equation ax4, if the coefficient that is written with x4 it's positive, we will get this graph. We will get a graph where we will have two minimums and one maximum in between. If the coefficient that is written with x4 it's negative or less than 0, it is less than 0, not 4. So if it's greater than 0 and if it's less than 0, you will get this graph. Just like this one. And in this case, you will have two maximum and one minimum. And if you have a positive coefficient in a cubic equation, you will first have a maximum and then a minimum. And over here, you will first have a minimum and then a maximum. So this is the difference. Moving forward, yes, one more thing that you should know is if we have any equation, the dominant term is the one that has the highest degree. So if I have any equation, for example, I have y equals to x4 minus 4x3 plus 5x square. This is going to be the dominant term. Dominant term. The one that is having the highest degree. On variable. So whenever you are given any equation, you will first write down the dominant term separately, and you will analyze that dominant term. And then after analyzing the dominant term, you can see which type of graph will get. For example, if you get a dominant term and it can be anything. It can be, for example, if I write it in a general form, dominant term, if you write it generally, it can be written as you have a coefficient a, and it's written with the variable having the highest degree n in any equation. So just by analyzing this dominant term, we can figure out the graph. So based on this, you have to check two things. You have to check whether this n, like the power, is it even or odd. And the second thing that you have to check is that is this coefficient that is written with this variable, is it positive or negative? And based on that, you can have four type of conclusions. So if I write it down, your power n, it can be even and it can be odd as well. And if we have the coefficient, if the coefficient of x is positive, or the coefficient of x can be negative. We have got four possibilities, four combinations. So coefficient can be negative if the coefficient of x is negative. So for all of these combinations, we will have different type of graphs. So this would be like kind of a grid. Okay, so if you have a power in your dominant term, if the power is a positive power and it also has a coefficient which is positive with it, you will have a graph. It would be like this. It would be firstly, then a negative, and you can say that these the turning points, they do depend only on the power. It's not necessary that over here you can see we have got 1, 2, 3, 4, and 5 turning points. But it's not necessary. You will have the turning points that will be according to the power that will be given. But generally speaking, you will have a graph which will look like this thing. But the turning points, they can differ. So it would be like this. If we have the power which is even, but the coefficient that is written, it's negative, then you will have a graph which would look like this. So we should like draw it with a dotted line so that you can understand that these terms, they are not constant. They will be according to the power that will be given in the question. So it would be something like this. It simply indicates that if the coefficient is negative and if the uh, power of n, it is even, you will get a graph which will have the maximum point first, then it will have a minimum point, and then a maximum point, and it keeps on repeating according to the power. Like we know that the number of turns, they are one less than the power of the dominant term. So it would be like this. Similarly over here, when the coefficient will be positive, we will have a minimum point first. So over here, the first point will be a maximum point, and in this case, the first point will be a minimum point. Same goes for the odd power, like the odd power, when the value of n it is odd, like 1, 3, and not 1 for 3, 5, and so on. So it would be like, you can have it like this. So its number of turns also depends on the power, but it would be generally like this. So when the coefficient will be positive, it would start from this point, and then it would start from, you can say that, the right top, and it will end at the bottom left. But if the coefficient is negative, then it would start from here, which is the top left, and then it would end at right bottom. So the graph would be something like this. Okay, one more thing that you should know after this, after understanding these basic graphs, is that you should know how do we consider those points where the value of x and the value of y is 0, which we called as x-intercepts and the y-intercepts. So how do we consider these points? So intersection. Okay, so if you are given any equation which can be factorized, for example, if we are given an equation which is like if it's directly given in this form, y equals to, you are given the factors x minus 2 into x minus 8 into x minus 9. So what does that mean? It means that the line or the graph, it would cross the x-axis at point 2, at point 8, and at point 9. How can we find that out? We can simply, we simply want to find the x-intercept, and we know that at x-intercept the value of y is 0. So x-intercept, to find the x-intercept, we know that we have to put y equals to 0. So 0 would be equals to x minus 2 and x minus 8 and x minus 9, like this. So from here we can see that the graph, it would cut the x-axis at this point, then it would again cut the x-axis at point when x will be equals to 8 and when x would be equals to 9. Similarly, if you want to find the y-intercept, you can have simply the value of x equals to 0. So to find the y-intercept, we know that the value of x would be equals to 0. Y-intercept is a point at which the graph cuts the y-axis. So at that point, the value of x is 0. You will simply substitute the value of x as 0 into this equation. So it would be simply minus 2, minus 8, and minus 9. And we will get 144. So whenever you are given any equation like this, you can consider these points when you will start drawing the graph. So for example, if we take an example now, for example, I am given an equation that I have to sketch a graph where y is equals to x cube minus 3x squared minus x plus 3. You can like factorize it, you can convert it into factors, and finally you will get x plus 1 into x minus 1 into x minus 3. Now if we want to draw the graph for it, how can we draw it? You can see that the dominant term that we have over here, it's x cube. This is the dominant term that we have. So if you look at this one, you can see that the power, it's an odd number, like n is odd, and the coefficient that is written with the dominant term, it's positive. So moving back to our grid to see that which type of graph would we get, you can see that for a positive coefficient and when the power is odd, we would get a graph that would look like this. It should be the graph. And how many turning points will we have? Over here you can see that the
3
no,
or 2, 2.
yes, the highest degree is 3, so the turning points would be only 2. So the turning points, they would be 2, and the graph would look like something like this. So it would be look like this. Now we want to sketch it, and from here, like we have converted it into this form, we have made the factors for it for this equation, and from here we can get the values for x-intercept. What are the values for x-intercepts that we can get? What would be the values?
1 minus 1 and minus 3. No, wait.
No, to find the x-intercepts, we simply put each of these factors equal to 0 separately. So x plus 1 will be equals to 0, so it means x would be equals to minus 1.
Minus 1.
Yes, for the second one, x minus 1 would be equals to 0, so it would give you x is equals to 1. For the third one, x minus 3 would be equals to 0, so it would give you x equals to
3.
3, not negative 3. So from here, you can see we have got the values for our x-intercepts, and now we want to find the value for our y-intercept. These are the values for x-intercepts. Now to find the value for y-intercepts, we know that at y-intercept the value of x would be 0. X would be equals to 0. Now you can simply substitute it back into this equation. So y would be equals to positive 1, negative 1, negative 3. So what would we get? Y would be equals to 3. So we have got the points. So we can see that the turning point should be 2. We have got this information that the graph, it will cross the y-axis at 0, 3, crosses the y-axis at that point, and we also analyzed that the graph will cross the x-axis at points minus 1 and 0, then at point 1 and 0, and then at point 3 and 0. Okay, now if we sketch the graph, can see that we need -1, +1, and 3. So it would be somewhere here. If it's -1, if it's +1, if it's 2, and if it is 3, it's 4. You can like draw it roughly, you can sketch it roughly. So we know that it should cross this point, it should cross this point, it should cross this point, and for y-axis we know that the y-intercept is at point somewhere like here. You can say it's here. So it should also crosses through this point. From which end do we need to start drawing the graph, and which would be the first turning point? Would it be a maximum point or a minimum point?
Minimum.
Yes, and from which end should we start drawing it?
-1.
Okay, yeah, it's up to you. You can start drawing it from here and from here. But if you start drawing it from lower bottom, it would give you a maximum point first. So you can keep this in your mind that you always start drawing it from the top right. This is the top right point. So you always have to start drawing it from top right. So if we draw it from top right, like from here, it should cross through this 3. It will cross it through point 3, and it would give you a minimum. So it would be like this. Then it will go down, and after that it will come up again to pass through this one, because we know that it is intended to give us a minimum point first. So from here it would give you a minimum point. After that it will go over here. We know after getting a minimum point it would give you a maximum point. So to give you a maximum point, it would then go to the y-intercept. After that it will move back down from here, and it would be like this. So you can see we have got 2 turning points. One is this one, and the other one is this one. So you get a minimum point first, and then you get a maximum point like this. Is it clear?
Yeah.
Okay. After this, yes, after this you should know some more general graphs. For example, if we are given an expression y equals to 1 divided by x raised to the power n, but x should not be equals to 0, otherwise we would get a error. So for x not equals to 0, what type of graphs do we get? If the power of n it's 1, like in the first case when the power of n it is 1, the equation would be y equals to 1 by x. So for any such equation, we will have a graph which would be like this. Or it would be like this. And in which case will we get this one? And in which case will we get this one?
Get this one if it's positive.
Yes, if the coefficient, for example, if I have a coefficient y is equals to 1 divided by ax, any coefficient that is written with this variable x, if it is a positive, you will get this figure. If it's positive, and if it is negative, we will get this graph. So it would be like this. This is when the power of the variable is 1. Then, but if we have a power of this variable as 2, in that case, if the power of the variable is 2, the equation would be like y equals to 1 divided by x square. So in this case, the graph that we will get, it would be either like this, or it would be like this. These are the two type of graphs that we can get. So for example, if I have a coefficient a with this term, so if the coefficient is positive, we will get this graph. If the coefficient is negative, we will get this side of graph. After this, you should know one more thing, which is the curves of the form. It's k x 1 by 2 and y is equals to kx minus 1 by 2. Or you can also write it like this. So the curves that you will get in this case would be, in the first case, you will get a curve which would be like this, where the power is 1 by 2. And if the power is negative, it would be like this. Y would be equals to x negative 1 by 2. Both of the coordinate x's, they are the asymptotes. What do we mean by asymptotes?
The line that don't like touch a
Yes.
certain like point on the axis.
Yes, very good. In this graph, you can see both of the points, they will be both of the coordinates, they will be the asymptotes. It means that the graph will keep on moving closer and closer, but it won't ever touch the x-axis or the y-axis. What does that mean? It means that it won't give you an x-intercept or an y-intercept. We know at x-intercept, it actually touches the x-axis, and at y-intercept, it actually touches the y-axis. But this graph, it has the coordinate axis as asymptotes, so it does not give you any x or the y-intercept. So we can say that the coordinate axes are asymptotes, no x or y intercepts. Same is the characteristic for these two curves as well. So I can just write it down over here that both of these curves, they like go closer and closer to the x and the y axis, but they never actually reach them. So they are also the asymptotes. The coordinates are asymptotes to the curve. And the asymptotes can be vertical or horizontal as well. Which of the coordinates will be a vertical asymptote and which of them will be a horizontal asymptote?
Mm,
This is a vertical asymptote. The y-axis is what we call as vertical asymptote, and the x-axis is what we call as a horizontal asymptote. Okay, moving forward, yes, you need. I need to tell you one more thing, which is just a minute. Yes, if you are given an equation, for example, if you're given an equation which is y equals to x minus 1 into x minus 3 square. Yes, what type of graph would we draw for in this case?
mm, is it quadratic? No, wait, cubic graph.
Yes, very good. It's cubic. So it would be x cube, and the coefficient it's positive because it's 1. So our graph would look like this, something like this. So what should be the point at which the graph would cut the x-axis or the y-axis? How will we identify the points? First, you have to tell me that how many turning points will we have? This is a cubic equation, so how many turning points will we have?
2.
Okay, so this is a cubic equation, so the number of turning points, they would be 2. Okay, now at what points will our graph cut the x-axis?
1 and 3.
1 and 3. Yes, but there is a difference. Over here, you can see that it is a single factor. Like this is a factor, but it has only a power of 1, right?
Mm.
Only has a power of 1. It means it indicates that the graph, it will cut the x-axis at this point. It will only cut it. Like cut means that it will only pass through this point when when the value of x will be 1. So it cuts the x-axis at x is equals to 1. But when you see a factor which has a power of 2, just like we have in this case, it has a power of 2. It indicates that you will have a turning point at this point. It means that the graph will have a turning point at x is equals to 3. So there's a difference. So when we plot it, so it would be 1, then it is 2, then it's 3. So we know it will start from the top right, it will come down, and it should give you a, which point do we get first? In this case, when the power is odd and the coefficient is positive, it will give you a minimum first. So from here, you will start, it will come down, and it will give you a turning point at this 3. It does not, it does not only cut through at this point, instead it will give you a turning point because the power on that factor, it was 2, the power was 2. From here, like you can see that the power was 2, so that's why it would give you a turning point at this point 3. After that, you can see that this one, it only had a power of 1. It means that it will only cut the graph. The graph will only cut the x-axis at point where x will be equals to 1. So after that, it would go up, it, and after that, it will come down, and it would give you a. So over here, you can see that it is only cutting the x-axis, not giving you a turning point at this point, because the power was only 1. When you have a power of 2 on any factor, it gives you a turning point instead at that point. So that's why at 3, we are having a turning point. At 1, we are actually, the graph is only cutting the x-axis. So this is the first minimum point that we have, the first turning point. And this one, this is the maximum point. So we have got 2 turning points for a cubic equation. Is it clear?
Mm.
Okay. If we see another equation, okay. So if we see another equation and we are given y equals to x squared into x minus 4 squared. Yes. Which type of graph will we get in this case?
Um, the power will be 4.
Yes, the power, the quadratic equation, like the dominant term, it would be x raised to the power 4. Very good. And what's the coefficient?
Coefficient meaning
Is the coefficient positive or negative?
positive.
Yes, it's positive. So what type of graph would we get? Just look back over here. You can see when we have a even power, because it was 4, so it's even and the coefficient is positive, so we would get a graph which would be like this. It gives you a minimum, a maximum, a minimum, maximum, minimum, like this, right?
Mm.
So moving back, how many turning points will we have?
3.
Very good. It means that the points that will be on the extremes or on the outside, they will be the minimums. Then in between, we will have a maximum, right? Right or not? Because we know
Yeah.
that it looks like this. So we know that the turning points, they are 3. So on the extremes, we will have the minimum. It would be like a minimum, then a maximum in between, and then a minimum again. So it would be like this. Now, how will we identify the points at which we will get the turning points? Looking at this one, can you tell me at which point will the graph have a turning point, or we are given any point at which the graph cuts the x-axis?
It's got the x-axis as
Sorry,
it's got the x-axis as at 4.
it would not cut the x-axis. There are two different concepts. This is what I'm trying to tell. Cutting the x-axis and giving a turning point at the x-axis are two different things. We only get the point where it cuts the x-axis is you will get it when the factor it only has a power of 1, just like we have over here. You can see that we are not having a turning point at this point, it is only cutting it. It just passes through this point, it comes from above, and then it cuts at this point, and then it goes down. It does not give you a turning point at this point because the power of this factor it was 1. But looking at the second factor, you can see it's x minus 3 and its power is 2. And whenever you have a power of 2, it gives you a turning point at that point. It would be x minus 3 would be equals to 0. So x would be equals to 3. It means that you will get a turning point when the value of x will be 3, and you will get the x-intercept when the value of x would be 1. So these are the two different things. So moving back from here, over here you can see that x has a power of 2. So we know that x square would be equals to 0 and x would be equals to 0. It has a power of 2. What's the value of x that we have? It's 0, and it has a power of 2. It means that will we get a turning point through this factor x square, or will we only get the x-intercept? When we have a power of 2, it gives you a turning point. So it also gives you a turning point, not the x-intercept. It means that you will have a turning point. You will have one turning point when the value of x will be equals to 0. And looking at this factor, we will make it like x minus 4 equals to 0. So x would be equals to 4. And you also have a power of 2 on this factor as well. So it means that you will also have a turning point at this point when x would be equals to 4. Clear or not? These two, both of them, they are giving you the turning points, not the x-intercept. So if we try to plot it like this is 0, this is 4. So we know it would give us a minimum point first. So it would be like this. And again, it would give you a turning point at this point. So you can see we have got 3 turning points, 1, 2, and 3. The first one is the minimum, then we have a maximum, and then a minimum again. So this is how we do this. Okay, if we see one example, if we are given an equation y is equals to x plus 1 into x minus 3 into x minus 4. How can we draw the graph for this equation?
Mm, it will be cubic,
Yes, it would be cubic.
and the x-intercept will be -1, 3, and 4.
Okay, minus 1, 3, and 4. Very good. From which end do we need to start drawing the graph?
Mm,
It would be -1, it would be 3, 4. So we start from the top right because the dominant term it's x cube. It's positive, it has a positive coefficient and the power is also odd. So you will start from this point. And is it giving you the x-intercepts or the turning points?
the turning points.
No.
No,
Do they have a
x-intercept, sorry.
Yes, these are the x-intercepts because all of them they have a power of 1. So it will the first point you start from here and the first point that you will get it will be a minimum point. So it will just come here, it will just cut through this point, then it will cut through this point, and then after that this is the first minimum point. After that you can also find the y intercept, for example whatever value it's at 6, for example. So it would cross at this point, and it would again come back and cut the graph where x is equals to -1. So you are having two turning points. The first one is the minimum and this one is the maximum. This is how we draw it. Is it clear?
Yeah.
Okay. We will continue it in every tomorrow's class. We will do the exercise and after that we will start doing the next chapter, like the next topic. Is that fine?
Yeah.
Okay. Is the time from the previous class covered now?
Yeah.
Okay. Take care then. Allah Hafiz.
Allah Hafiz.